Hey everybody, welcome back to Weaponized CAD. I'm your host Danny, and today we're going to talk about hatching and boundary polylines. This is going to be a quick video on how to use them, where to find them, what they do for you. So let's get going. The hatch command is in the Home tab in the Draw panel in the lower right hand corner, and it defaults to hatch. It's this box with these tiny blue lines going through it. So we're going to click it. And down in the command line, it's going to ask us to pick an internal point or select objects. Now, depending on what you're hatching, you're going to either pick that internal point, like you see my cursor is just hanging over our bat symbol here, and it's giving us a preview of what the hatch is going to look like. There are other times where you want to select objects. You might have things laying over top of each other. You might want to hatch something that's underneath, that's above, not the whole thing. Picking the internal point is the default for the hatch command and is not always the best way to do it. The reason is that picking the internal point forces AutoCAD to look at that point and essentially send rays out away from that point to find an enclosed object. Now, we already know our bat symbol is closed, because if we hit escape, we select the bat symbol, we go to our properties. Down in the bottom, it says closed, yes. So picking an internal point of this bat symbol is going to be easy. You can let it pick the internal point because we know for a fact that it's a closed object. Let's go back to the hatch command. Let's hit select objects, or S enter on the keyboard. What this allows us to do is select the objects that we want to hatch. So I'm going to select our bat symbol, and then it's going to restart the hatch command. So if you had a number of hatches you needed to create, you could hatch the bat symbol, hatch something over here, hatch something down here, hatch something over here, or just right-click to end the command. Now, this is the default hatch. If we select it, our ribbon panel changes. We have the pattern panel that shows up, and inside the pattern panel are up and down arrows, and then there's this line with an arrow below it. If we click this, it actually expands our panel so we can mouse wheel scroll through all the different hatches. So if we wanted to put stars in there, we can select stars. I'm going to hit that again. If we wanted to do zigzags, we can do zigzags. So we've chosen our hatch pattern. Next to the pattern panel is the properties of the hatch. So we have the pattern up here. We can change it from pattern to solid. Solid also shows up in your pattern list. So let's say we had it on angle, and we don't really want that. Up in the pattern list, solid shows up. If you're scrolled way down, you can just use this drop down right here to get to solid. You can also choose a gradient, you can choose the pattern, which we already showed, or a user defined. Below that is the color of the hatch. If you expand that, you can choose from the color palette here, or you can click more colors, which opens the select color dialog. Now, AutoCAD defaults to 0 through 255 colors. But you also have the True Color tab, where you can actually get crazy with the color. And then there's all the different color books over here. If you know for a fact you need Pantone, metallic, something or other, you can actually scroll all the way through all the Pantone colors and pick something crazy like Pantone 8543C. I'm going to hit escape. I'm going to select my hatch again. Next, we have the hatch transparency. So if you don't want it to be super loud, you can actually pull the slider, or you can type the number here. Now, because this is a solid hatch, angle is grayed out. So let's go back to our stars hatch so we can actually see what it's doing. So the hatch transparency, as we're moving the transparency, it's going to increase and decrease the transparency of the hatch itself. You can also change the angle slider. And you'll notice that even though these stars would be shooting outside of our object, it's automatically clipping it at the object itself. Then you have your hatch scale. So if we said 2, it's going to increase the hatch size. If we said 0.5, it's going to decrease it. Set origin, we don't really need to worry about right now. This is if for some reason you select something and the origin shoots way off in the distance and the hatch pattern isn't looking correct or doesn't display at all. Sometimes hitting this set origin is telling it, I want the origin of this hatch to be inside my object. So you'll notice I clicked it, it kind of adjusted the hatch a little bit. That's okay. Associative means that it is associating this hatch with this boundary line. So let me show you again. If we select this hatch, associative is automatically checked because of the nature of this hatch command. It defaults to associative. And the reason for that is, watch what happens if we grab our boundary and we expand it. The hatch is actually recalculating where it needs to be and hatching inside of the new area. If we don't have associative checked, we deselect associative, it's actually going to gray out, and we grab our boundary and we move it. The hatch is now no longer connected to our boundary object. So if we change our boundary object, the hatch does not move with it. The hatch becomes its own entity, essentially. So I'm going to select the hatch, and you'll notice we have grips all the way around the hatch, but they are not the same grips as the grips around our polyline. Undo a couple times here. Let me select the hatch again. Keep associative on. It's a good thing to have on unless you absolutely need it off and you need to adjust just the hatch. Annotative, if we turn annotative on, it's going to adjust the hatch scale based on our annotation scale. So let me set this back to 1:1. This is a 1:1 hatch. Now if we set it to 1:2, it's going to make it larger. Let's say set it to 1/4 inch equals a foot. It's going to make it humongous. Scroll down, let's do 6 inches equals a foot. It's bigger. So that's what the annotative box means. And it's good for when we get into our sheet layouts and we're actually putting viewports in. We're going to be worrying more about annotation scale, things like hatches, things like dimensions, text. All of that is going to be controlled by that annotation scale. And the reason is because if we are looking at a viewport that's set to a really, really big scale, like 1 inch equals 200 feet, this hatch would be very, very hard to see if it wasn't automatically updating based on this button here. Match properties means that if we have, let me copy this over. We have a second hatch here. I'm going to change it to this hatch. The match properties up here lets you match the properties of the hatch you have selected with another one. So that's hatching, which is also known as boundary hatching. If you type B hatch, you get the same command. It's the same command as up here. We escape out of B hatch. We hit this. It's going to give us just the hatch command, but it's the same idea. B hatch is boundary hatch. Hatch is hatch. Now let's erase that hatch. Let's just kind of eyeball this back into place. Okay. Underneath the hatch command is also the gradient command, which automatically fills your object with a gradient, which is a selection once you have a hatch, pops up in the ribbon. There's also the boundary command. What the boundary command is going to do is it's going to allow you to take the inside of an object and create a polyline that is closed inside of that object. Now, our bat symbol is not a great example because all it's going to do is essentially replicate the same thing. But if we say, okay, let's pick points. I'm going to pick inside our bat symbol. You're going to notice that the actual border of the bat symbol image will highlight, and that's because AutoCAD is shooting rays out from wherever you click, trying to find an object to stop at. You'll notice that if we zoom in, this is actually dashed, which means that it found the inside of our original bat symbol polyline. I'm going to right click. Now, if I select this bat symbol and I move it out of the way, we have this bat symbol here, and we have this bat symbol here. This is the boundary poly. This is our original polyline. Erase that. Now, let's say we had something in the middle here. We put a rectangle right in the middle. Let's go back up to the hatch command. Let's pick an internal point this time. You notice that it's going to hatch inside this area, but because this rectangle is not inside of this area, it's going to ignore it. We can also hatch inside that rectangle if we need to. What it's going to do when we right click is it created this hatch inside of the bat symbol, but outside of this rectangle. Let's go back to hatch, and we can hatch inside there if we want to. Single left click and then right click to end the command. That's two separate hatches. Let's do it again. This time, let's select objects. We're only going to pick the bat symbol. And because we only picked the bat symbol, it's going to ignore the fact that there's another piece of geometry in the middle. But we selected the bat symbol. Let's pick this rectangle. It recognizes the fact that it's trying to hatch inside of the first object and outside of the second object. Now, this doesn't work 100% of the time, but it works most of the time. Same thing for the boundary poly. Let's go back up here to the hatch. Let's hit the down arrow. Let's go to boundary. This island detection button is essentially the same thing that the hatch command is doing. It's looking for an island. This rectangle would be considered an island. So if I click pick points and I pick inside of our bat symbol, you're going to notice that it actually put a polyline around that rectangle. And the reason is because that's an island. So it outlined our bat symbol, and then it outlined the island, because we implied that by clicking in this area, we don't want to include this. But because it's just two separate polylines, if we move these over, everything is maintained. So that's it. Hatching boundary polylines, it's essentially the same idea, because the hatch is automatically creating a boundary, and the boundary polyline is ensuring that something is enclosed. Now, one more thing to talk about with boundary polylines. I'm going to use the break command and break the bat symbol apart. There's a hole here now. This is no longer closed. Closed, no. If we hatch and we pick an internal point and select inside of here, it's not going to hatch it because it's not closed. It's leaking out this side and it's just shooting out into space. Instead, what it did is it actually hatched behind this image and hatched the boundary of the bat symbol image itself. To combat this, we click Settings. The Settings brings up the Hatch and Gradient command menu. What we have in here is the ability to set island detection, and it actually shows you the display style. So normal island detection, it's going to hatch outside of this object. Outer island detection, it's going to hatch all the way outside this object. And ignore means that it's going to ignore any islands on the inside. Now, what's important here, this menu does not come up unless you hit the hatch command and you click the settings button down at the bottom. And then further, you have to click the arrow down here to get to what's called gap tolerance. Gap tolerance is how you tell the hatch command or the bpoly command, the boundary polyline command, that even if you find a gap, I want you to fill it at a certain distance, a certain number of units. So when we tried to boundary hatch or hatch the bat symbol with this break in it, it couldn't do it because it's not a closed object. If we change this tolerance, let's change it to 6 inches, which might be overkill, but we're going to give it a go anyway. We're going to click OK, and we're going to click in here, and it's still not going to work. Let's go back to our settings. Let's set that to 1 foot. Add pick points. Still no good. The AutoCAD hatch and the AutoCAD boundary polyline command are very particular about the objects that you try to hatch or put a boundary around. If they're not closed, that causes a problem. Gap tolerance sometimes works, but sometimes it doesn't. It's better to find this break and just close it with the grips. Even though this object is not closed, even though those 2 grips are now touching, the boundary hatch will find the inside of that object because those 2 grips, those 2 endpoints are coincident. Same thing goes for the boundary polyline command. Hatch, you're going to use pretty often. It's a good command to have. It's a good way to determine, to set things aside from other things. Might be something that you need to show as filled, might be something you need to show with something crazy like stars in it. The boundary polyline command you're probably not going to use as often, but I wanted to show it to you because it's in the same pull down as the hatch. Hatch, boundary. So that's it for hatches and boundary polylines. Like I said, boundary polylines you're not going to use very often, but they work hand in hand with the hatch command, because if you hatch something, the boundary that it creates for the hatch is essentially a boundary polyline, to where if you were to explode the hatch, it would give you that boundary on the outside of the hatch. And that's it for this episode, guys. Thanks for coming. See you in the next one.